This may just seem like some gratuitous violence, but there's actually some really interesting science going on when you compare these two impacts. You would think that doubling the speed would give you twice the severity of the impact, but the physics says you're actually looking at more like 4 times the severity of the impact. Our sensors are showing 3 times the G's, and our wreckage is showing about twice the damage. So what's going on here? Well, just like this can, the more I crush it, the more it resists crushing. There's some complex physics going on here, but you don't have to be a rocket scientist to understand it. The cars speak for themselves.
They certainly do. And after 2 spectacular crashes, they have their benchmarks for car carnage.
Well, we've got our data points.
And they are lovely. I guess it's time to move on to the main event.
Yep.
This car right here hit a wall at 50 miles an hour. This car hit a wall at 100 miles an hour. I think the difference is pretty clear. The question is, when we smack 2 cars together at 50 miles an hour, are they going to look like that, or are they going to look like this? We're going to smash 2 more cars just to find out.
It's the final act of Carmageddon. 2 cars in a 50-mile-per-hour head-on collision.
Here's how this breaks down. At this end of the track, the yellow car.
And at this end sits the orange car.
And here in the middle, these 2 cars will meet in a 50-mile-per-hour handshake of destruction that will hopefully answer all the questions we have about the crash forces involved.
Adam's predicting those answers will give the thumbs up to Newton.
This one has really been a brain bender, but I have a prediction for this final experiment. I think that when all is said and done, it's going to prove that Jamie was wrong and that the fans were actually right. That when these 2 cars hit at 50, they're going to look like the car that hit the wall at 50, not the one that hit the wall at 100.
And Jamie agrees.
Based on our small-scale testing, what we should see at the end of this head-on collision should look pretty much like the 50-mile-an-hour crash against a wall.
It's crunch time for a force impact. Will the full-scale test prove the fans right?
That's it. Well, I think it's time to do the final test. They're all set up.
It would seem so. I'm going to call it. Bring on the head-on collision.
From each end of the 1,280-foot track, the identical 1.5-ton cars take off. Both cars gain speed as they head headlong down the track towards their head-on collision. Then, as both cars reach 50 miles per hour,
it's about to happen.
The cables uncouple.
That was spectacular.
What can you say?
What can you say? That breathtaking finale is the final piece of their physics puzzle. And as the Mythbusters survey the wreck of a 2-car 50-mile-per-hour pileup, they're playing Spot the Difference.
There's a windshield between them.
It's pretty evident, isn't it?
It really is.
It looks just like the 50-mile-an-hour against a wall crash.
And nothing like the 100.
Nope.
Amazing. This tells me the whole story. I don't need to see the accelerometer data or anything. These 2 cars, which hit each other at 50 miles an hour, look exactly like the car we smacked into the wall at 50 miles an hour. That tells me everything I need to know.
Well, the figures are in. The orange car got 52 Gs, the yellow car got 58 Gs, which, give or take a few Gs, is the same as what we got against a wall at 50 miles an hour.
Gee whiz. And the damage data backs up those numbers. Both of the cars are virtually the same length as the 50-mile-per-hour wall test at 11.5 feet. And after a spectacular spree of automotive mayhem, there is irrefutable proof that those physicist fans had it right. Newton's third law, every action has an equal and opposite reaction, holds true. Although the two-car crash at 50 miles per hour doubles the speed, the energy of the crash is transferred to twice the mass, halving it, resulting in a crash that looks like just one car into a wall at 50 miles per hour.
I made a statement that two cars hitting each other at 50 miles an hour was the same as one car hitting a solid wall at 100. That was a mistake, but you know what? I'm okay with it. That's how you learn stuff.
I love smashing stuff for science.
One way or another, it's all just shrapnel.